Hello from Ohio and welcome. What does this Halloween candy bowl, this half a magic wand, and a drawer full of junk have to do with this Christmas decoration? Stick around and find out. You don't have to have a degree in engineering, be a product design specialist or a professional computer programmer in order to make some really cool things on your own. Let's learn how to do it together on Just Making It with Josh. This time, let's take a look at this Christmas decoration I designed and built. As you can see, when it's plugged in, it just has these green trees and a little blanking on the base. But when you press this button, you get a light show with music. What's really neat about it is that it doesn't have to be the same show all the time. You can change it up to play different songs and light shows in the future if you really wanted to. So what does this Halloween decoration, this plastic wand, and my junk drawer have to do with this Christmas decoration? Well, this Halloween decoration was one of my first electronics projects that I kind of came up with on my own. As you can see, part of it includes these red LEDs. I only needed a small strip of the LEDs, but I had to buy a whole spool for the project, so I ended up having a lot left over. Naturally, I just kept them, assuming I would eventually come up with a project for them. Turns out eventually only took a couple of weeks to come about. I was talking with my kids about what we should build for Christmas. I was hoping to make building new decorations a regular tradition in the house. In bouncing around ideas, I thought about those extra LEDs and decided that whatever I built should use them. And since I already had them, I wouldn't have to be buying all of them. Less things to buy is always a plus. Now, after talking with the kids about making a Christmas decoration, we pretty quickly decided that we liked the idea of making light up Christmas trees. I knew we'd have to have some kind of base to set the Christmas trees in. That's where the wand comes in. You see, I made a magic wand for my friend's daughter's birthday, something she really wanted. And the filament I chose looked kind of woody to me. I saw the wand while thinking about the Christmas project and realized that same filament would make a good looking base. Plus, again, I already had it. So lastly, while trying to figure out what exactly I wanted to do, I started looking through my junk drawers and came across a box labeled Raspberry Pi. I bought it several years ago, did a few things with it, but I never actually used any of the breakout GPIO pens on it. I thought this project could be a perfect use for it and a chance to use those pens that I never actually had the chance to play with. Which brings me to something I like to keep in mind when building projects, which is start with what you have. By starting with some of the things I already had laying around, it really helped me keep costs down. And it also provided some bounds within which to flesh out my ideas. Having lines within which to paint and color is always helpful, I think, in coming up with creative ideas. So now that I knew I was going to use my Raspberry Pi to control individually addressable LEDs to light Christmas trees, it was time to take my vague concepts and start turning them into an actual project. So the first step is to spend some time thinking and researching. It can be tempting to jump right into designing your ideas in FreeCAD or other software, but I'm convinced that's a mistake. In my experience, it's far better to spend some time doodling and thinking about challenges and potential pitfalls up front. It'll make your designing easier later. If you just jump right into designing, I find you're more likely to make some design decisions that will be harder to fix later on, and it'll just be kind of a pain. So what was some of the thinking and researching I did on this project? Well, to start with, I made a list of what I wanted my project to do. I wanted it to be able to switch on and off. I wanted it to be able to plug into the wall. I wanted it to have a button that started a light show, and I wanted that light show to be synced with music. Every year at the Columbus Zoo here in Ohio, the zoo holds an event that they call Wild Lights. At the large pond near the front, they have a light show that's synced to music. I wanted this project to capture some of that feeling from that particular light show here at the house. Just doing a little bit of research on the internet took me to a FALCON player for running the Raspberry Pi and a program called X-Lights for creating the light show. It's amazing the amount of information that just a quick Google search turns up to help you get started on projects like this. I drew some pictures of what it might look like as a concept and made notes as I went. I firmly believe in doing all this on paper. I'm not an artist. You don't have to be an artist. Your doodles, I think, can actually just be really helpful. Just the physical act of drawing them out will help you tremendously as you start designing things in FreeCAD. Let's take a look at the parts we're going to need, starting with the electronics. First, powering all of it is going to be a Raspberry Pi. This is a Model B I happen to have lying around. I went ahead and got a ribbon cable to put onto the 26-pin GPIO header. Makes things a lot easier. We'll also need a 5-volt DC power adapter. I went with 3 amps. I wouldn't go with anything less than that. You can power a Pi with less than 3, but you're going to want that extra power for the LEDs we have in this project. We need a small prop speaker. This is an 8-ohm 1-watt speaker I got from Adafruit. I'll put a link down in the description. I absolutely love this little speaker. There's a small audio adapter you're going to want to put on the end of this. It's 3.5 millimeters. We're going to need a Wi-Fi USB adapter for the Pi. It makes testing a lot easier. We'll need a USB audio out for the Pi as well. We need a SD card to store and run FALCON Pi player. We'll need a 74 HCT 245 integrated circuit. This is for shifting the level of the voltage coming out of the GPIO pins. We'll need a small button, an on-off switch, 3 resistors, one at 220 ohms, one at 1K ohms, and one at 10K ohms. A barrel adapter. Make sure you get one that matches that DC adapter you got. This is just a breakout board for the Raspberry Pi for the GPIO pins that the ribbon cable can connect into. Mounting all of this, you're either going to want to use perf board or a breadboard. In an ideal world, perf board would be better, but I just don't solder well. And so I'm going to use the breadboard for this. Lastly, we're going to need some individually addressable LEDs. These are really neat WS2812B individually addressable LEDs. After I had a chance to think through all of the elements that I wanted in this project and think through some of the pitfalls and challenges I might face, I switched over to FreeCAD for the actual designing. As you can see, this is just the Christmas tree. All right angles or sharp angles, nothing all that fancy looking to begin with. But I made sure as I was doing this to use some parametric design principles. So I have a spreadsheet with all of my important dimensions on it here, in millimeters of course, and then set up aliases for each of them so that I could reference them in my project itself. By doing this, it meant that if I wanted to change, for example, this height here, which is the same on all of them, I just had to change it once in here and it would go through each of those individual constraints and make sure that they got applied. This is important because if you have things that are dependent on each other's dimensions, if you change it in one spot, you might forget to change it elsewhere. And so I think it's helpful to do it this way. So once I put in my design here, I just came over, I did a revolution, did a small fillet to round off the corners, and that was the Christmas tree. I was then able to make a smaller version of it, again by just changing the numbers here in this spreadsheet, and that gave me all of the 7 of the Christmas trees that I would need. Now the base itself was significantly more challenging and really took quite a bit of time. It's the new kind of principle for me was figuring out how to put this kind of holly and these lettering on the curved surface. To do that, I downloaded and installed this Curves workbench. There's some great documentation and YouTube videos out there on it. I highly recommend doing it. But as you can see, there's quite a bit going on with this particular part. But at the end of the day, none of it was all that complicated. It just took a lot of time and a lot of thinking and a lot of testing. Powering all the lights and sounds for this project is going to be our Raspberry Pi running a program called FALCON Player. I'll put a link to it down in the description. This is version 3.6.2. I'm using an old version simply because I've got an old Raspberry Pi. If you've got a newer model, make sure you use the most recent version. One of the things I'd highly encourage you to do is to follow the tutorials out there in getting that installed on your Raspberry Pi, flashed onto it in the initial setup. If you use that wireless card, USB card that I talked about in the parts list, it'll make things a lot easier because your Raspberry Pi won't have to be right next to your router the entire time. So we'll use X-Lights to create the light and sound show for our project. To get started, we need to create a controller. So choose Add Ethernet, come up here, give it the IP address of your FALCON player, and then it's helpful to give it a name, so I'll call it Pi Player. The other thing that's important on here is to make sure that your protocol is listed as E131, that your vendor is listed as FPP, and that your model is listed as Pi Hat. Once you've done that, you're all set to go with the controller. So then we add a custom layout. This is going to be the custom layout, and you can see what I've used here, but let's show how to make that real quick. You'll choose Create New Custom, and then draw it on there. We need to come down, change its port to number 1. Make sure that we're using the right light setup. So for example, I'm using the WS2811, which is going to work with the lights that we're using. We then need to create our custom model. So come in here to model data. It's helpful to make this size a little bit bigger so we can see what we're doing better. And then we need to draw our model in the order that we want the wiring to run. So choose Active and Auto Increment. And we need to put 36 lights in for the base, so that's 9 in each quarter. So start here at the beginning, just click on a square, and then click on the next square, and it will increase and give each pixel a name. And then we'll come all the way around until we have done all 36. Doesn't have to be perfect. We just need the general shape of a circle. And you can see what we have down here. Then we'll do 4 for each Christmas tree, starting at the front and working our way clockwise this time, so that our wiring will be easiest to run. So we need 6 Christmas trees at 4 pixels each, and then 1 final Christmas tree at 5. And that'll take us up to our entire model. So we'll go ahead and hit OK to save. We'll give this a name, for example, Tree Project. And then lastly, before we leave this screen, we need to create some submodels for each of those individual elements that we added. So we'll add a new submodel. We'll call this the base. And we know that that was LEDs numbered 1 through 36. When you hit tab, you can see that, make sure that you've got the right things lit up. And then we'll add all of our trees in order. So this would be tree number 37 through 40. Tree 2 would be the next 4 lights. And then we'll add all of our trees in this manner. And again, once you get to the main tree, your last node should end with 65. So we'll hit OK. And now we're ready to move on to actually creating our sequence. So we'll come over here into the sequencer. We'll come up here where it says New Sequence. We're going to do a musical sequence. So we'll find our light music, double click it, and then we'll choose 20 frames per second. We're going to choose all models and quick start. You can see that we've got our music up here. We've got our tree project. When you double click on it, we have all of the elements of our tree project. Now we can drag and drop in elements for our show. And this is the sequencing is where you'll probably spend a lot of time getting your elements to line up with what it is you want to go along with each bit of the music. You'll find lots of already pre-programmed examples out there in Xlights to see how things work, as well as instructional videos on YouTube that can go into the details of sequencing. Once you have your sequence the way you want it, we'll come up to Tools, FPP Connect, and it will find your FALCON player. You're going to put a check mark. You're going to check the box next to the player or the sequence you want. If you want to upload your music as well at the same time, you choose Media and then hit Upload, and it will add those directly to your FALCON player. You're then ready to move to the FALCON player interface to finish up setting up your show. Once you have everything set up and you have imported your Xlight sequences, come over to File Manager just to make sure they're actually sitting there. So there's our two Xlight sequences that I'll talk about later and our audio. So what we're going to want to do is make a couple of playlists. Our first playlist is going to be the show itself. This is what we want to play when we push our button. And that's just going to be a media and sequence as our type. Make sure you give it a name. Choose the sequence that we want to play, in this case Final Christmas Show, and choose our music. Hit Add and it'll put it down here, and then hit Save. Make sure you hit Save. We'll do the exact same thing with our background. So we'll do a new playlist and hit Add. It'll pop up down here. For the background show, we're just going to want to do a sequence only because we don't need any music. Make sure you save everything. And then you're going to want to set up an event because you're going to use the event to actually play that show when you press the button. So we'll just we would just choose to add an event. That'll bring us to this editor. Give it an ID, a name. You're going to choose Start Playlist and the playlist that you're going to do. Make sure Repeat's not checked here. And then you'll save your event. Next, we need to go over to the setups. So first, we're going to choose our channel outputs. We need to let the Raspberry Pi know that it's going to be putting everything out through our GPIO header. So come over here to Pi Pixel Strings, choose Output Enabled. Make sure this box is checked. I can't tell you how many times I got frustrated because I forgot to check this box. On the protocol, it's going to default to that WS281X. Give it a name. Our starting channel is going to be 1 and our pixel count is going to be 65 because that's how many pixels and individual LED lights we have on this project. Once that's done, hit Save here. Again, don't forget to hit Save. Very important. And then you're going to restart your FALCON Pi player. Once it restarts, you'll come down here to the GPIO inputs. This is where you're going to tell the Raspberry Pi, hey, go ahead and run that show when we hit the button. So enable BCM25 wire number 6, and then on the falling event, choose Play Show. That's simple. Restart, and you're ready to go on that. Lastly, we need to set up a scheduler. Just choose you'll add, and then you're just going to choose to enable. Choose a date well in the past and an end date well into the future. That way it's always going to run. The playlist we're going to do is that background or base playlist is what I called it. We're going to do it every day, and then if you choose a starting time of all zeros and an ending time of 24 and then choose repeat, then it will default to whenever the project is on, is going to play this playlist. On the stop type, choose graceful. I went round and round on this because I had hard stop, and all it ended up doing was blinking all the time. By choosing graceful, it seemed to work better, and it still would allow me to interrupt it when I pressed the button. Restart your player one more time, and when you do, you'll be all set to go. To begin with, we will need to wire together our LEDs for all of our lights in this project. We'll need a total of 65 LEDs cut into 8 strips. One strip will be 36 LEDs long, 6 strips will be 4 LEDs long, and 1 strip will be 5 LEDs long. Then we'll need 24 separate wires cut at approximately 180 millimeters in length. Wire 3 of those to the inside of the 36 LED strip, and then another 3 to the outside of the 36 LED strip. We'll then wire those together through the 4 LED strips, all 6 of them, and then ending with the 5 LED strip. That will complete all of the wiring for our LEDs. We'll also need to put together all of the wiring for the remainder of the project following the wiring diagram. I'll have a link to it in the description below so that you can download it, but follow it carefully and put everything on a breadboard. So let's turn to our breadboard. This is where my electronics project starts. You know why? Because I don't know much about electronics. I know just enough to be dangerous. And so if I was to go ahead and just go at it and solder everything together, I would be taking it all apart multiple times in order to get it right. So I encourage everybody to start with a breadboard just to try things out and make sure it's all going to work before taking the time to solder it together. So as you can see, we've got our Raspberry Pi all hooked up and running, and we're using a ribbon cable over to this breakout onto our breadboard. This makes it so much easier to access all the GPIO pins on that Raspberry Pi. We've got our Adafruit speaker hooked in. We've got our NeoPixel lights hooked up. We have our integrated circuit. It's connected to that GPIO, and that signal is coming out at 3.3 volts. The purpose of this integrated circuit here is to increase the voltage on that from 3.3 volts up to that 5 volts that's needed for these individually addressable LEDs. And then we have our button in line. So let's go ahead and plug in those lights, make sure that they're working. They are. Good sign. So then we go ahead and push our button, and we should see everything turn off. And then just a moment later, we should start seeing those lights twinkle. And you probably can't hear it on your end, but the sound is working. That means everything is a go, and we could go ahead and get this mounted into our project. To install the barrel connection to the base, we'll take our barrel connector with its 2 leads on it and slot it in through the side hole for the barrel connection, pulling it all the way through. Then we'll take our jacket and slide it up over the wires and have them come out through the bottom. Now the jacket itself is threaded so that it will thread right onto our barrel connector. When you're doing this, make sure if you've got pins on there that you don't bend or break off your pins. Then simply twist it on, make sure your connection is secure, and then you're all set. You've got your barrel connector where the power will come into your project, and then you've got your 2 leads here that you'll connect up to the rest of your electronics inside. Now let's install our on-off switch and button. Grab the leads of the on-off switch, and we'll just thread those right through the hole in the side of the base. That on-off switch fits snugly and just pushes right in place. Now for the button. As you can probably see, I've already installed the brown backing piece to the button with just a little bit of super glue. So what we'll do at this point is take and put a little bit of glue right on those other ends of the brown backing piece. And this will hold it in place firmly to the side. So we push it through on the inside, hold it in place while it dries quickly. And as you can see, there's our button and our on-off switch already in place, ready to go. So now we take our long string of 36 individual LEDs, and we're going to wrap those around the inside of our base. To do that, simply peel off that blue backing adhesive sticker And you're going to start at the very front and work your way around, pressing firmly as you go until you get all of them in. It should come and wrap around right back to the front. Then make sure that all of your lights are down through the center. Grab your inner plate. Make sure that you find the slot that has a hole right next to it. That's going to go toward the front, and we'll go ahead and put that in place. Now we're ready to wire up our trees. Running the lights for the Christmas tree isn't terribly difficult as long as you take your time, go slowly, be patient, move wires out of the way, and don't force things. All you'll do is, starting from the very end of your lights and coming underneath, you'll push it up through the bottom plate. You'll see it come out on the top side. You'll push all of those through until you get to the string that will go on that Christmas tree. Again, take your time, move things around if you need to. The last thing you want to do is have to resolder something inside this plastic. Sometimes the wires just want to be twisted a little bit. Once you get them through, generally they work themselves out just fine. So once you get your light up through, take off that adhesive backing. And then put it right on the front of your display. Get it twisted around here, get it lined up, press it firmly in place. Then carefully bend the wires over at the top so that you don't mess up with any of your soldering. And then you'll feed it right back through, going all the way through until you get all of the trees lit. They'll fit snugly in that back hole. Again, if it doesn't want to just go right through, take a moment, make sure that everything's lined up, and don't force it. This project's relatively forgiving, but you're still working with some rather thin pieces of plastic and a lot of soldered joints. Once you have all the lights run for the tree, now it's time to plug everything in and make sure it works. You don't want to have all of the trees glued on and your base glued in place only to find out that what you did accidentally broke some wiring or something. So get it in, plug it in, make sure it works. Then and only then should you go ahead and put the final touches on by gluing down your trees and attaching everything to the base. At the end of any project like this, I think it's important to reflect on how things went. First, the good. Overall, I'm really happy with this little decoration. I've never designed from scratch and built anything this complicated before. That it works is still exciting to me even several days later. Now the things I do different. First, I'd add a small red LED near the light switch that would be wired directly to the power input. There's a not insignificant delay between turning the decoration on and when it actually starts because of the age of my Raspberry Pi. An LED would at least be helpful to let me know that the project is actually on while it's booting. Second, I would have put everything on perf board instead of a breadboard. My soldering skills or lack thereof were the barrier here, but it would have been tighter on the inside had I done that, and I'm going to strive to do that in the future. Third, I would have added an Ethernet port on the outside. I can still log into the Raspberry Pi via Wi-Fi, but I can see some advantages to being able to use an Ethernet connection to log in as well. Lastly, I think doing some finishing work on the base would be good, perhaps painting the holly leaves and the words. All that said, I really am pleased with how this turns out. I hope you'll give it a try by going over to Thingiverse and printing it yourself. If you do, let me know in the comments how it turned out, what songs you used, what kind of lights show you created. Always take time at the end of a project like this though to reflect on how it went. Learn from the goods and the bads so you can improve and make your next project even better. So if you enjoyed this video, I hope you'll like or subscribe, and I look forward to seeing you all again in our next video.